Hey, algebra, here's our do now for today. We'll check out if 0, 0 is a solution to the following inequality: y is less than 4/3 x minus 5. Hit pause while you work on that, and go ahead and resume once you got an answer. Hey, welcome back. So I just took my 0 for x and my 0 for y, plug those in to the inequality, followed the order of operations, multiply 4/3 times 0 first, and then subtract 0 minus 5. What I got to 0 is less than -5, and I asked myself, is that true? No, that's not true. 0 is not less than -5. So that is not a solution. So today we're going to look at graphing linear inequalities. Our learning target is just what you'd imagine. We'll be able to graph a linear inequality. Sometimes people call these XY inequalities. We'll be graphing on an XY coordinate plane. And so this is the part of the curriculum where we start taking previously learned topics like inequalities and other previously learned topics like graphing lines. We bring them together and look at more complicated applications in the algebra world. So here goes. Graphing linear inequalities. We'll start from what we learned before about graphing lines. And so if we were to graph y equals 4/3 x minus 5, we're going to start from the y-intercept at -5. Down here on the y-axis, -5. We'll use the slope highlighted in green there to find the directions to the next point. So 4 is going to be the rise. We're going to go up 4 spaces. 3 is the run. Always go to the right for run. So start at the blue dot, up 4 spaces, over 3. There's my next dot. I went ahead and repeated that process again, up 4 and right 3 to get another dot. So I had some more dots to work with, draw that straight line. Okay, so we're going to combine that with what we've been learning about inequalities. It's essentially 3 steps to graphing a linear inequality. The first one is we have to decide what type of line style to use. So just like when we were graphing inequalities on a number line, we had different styles of dots. We had open dots and closed dots. We have kind of the same, it's the same idea, kind of an equivalent version, but with lines. So for the symbols less than and greater than, we use a dotted line, or if you want to call it a dashed line, either way, it doesn't matter. And for the symbols less than or equal to, greater than or equal to, we're going to use a solid line. Okay, so make that decision first of all. Then, once we know what type of line style to use, we go ahead and graph that line using slope and intercept, or whatever form the equation is whatever form the inequality is in. We're going to graph it. And then finally, our third step here is to shade. So we're either from that boundary line, we're either going to shade above it or below it. In order to determine which is the correct part of the graph to shade, we're going to use a test point to decide where we shade. 0, 0 is my recommendation. That's always going to be the easiest test point. But the only rule we're faced with here is that our test point cannot be on the line we just graphed. And so if your line goes through 0, 0, you'll have to pick a different test point. You can use any point you want, but 0, 0 will be easiest when it is possibility. So let's take a look at an example. Not that one. Let's take a look at this example. So y is greater than 2/5 x minus 1. All right, so I already started this a little bit. So I looked at the inequality. It's highlighted in yellow. Get that inequality symbol says greater than. And since there is not an or equal to on that symbol, I know that I should use a dashed line or dotted line. Either way, right? So then I'm ready to start my graphing process. So my y-intercept is at -1, so highlighted in blue, and I got my blue dot here at -1. Green highlighting is the slope, rise of 2, run of 5. So from the blue dot, I go up 2 and right 5. There's my next point. I went ahead and connected them, drawing that as a dashed line. Okay, so some people will sometimes say, but wait, when we were graphing inequalities on a number line, a greater than symbol, we always use an open dot, that hollow dot. And so why did I not use hollow dots here? My response to that is, wow, that's an amazing memory. You're totally right. And this is not a number line. And so we don't have to worry about open dots or closed dots. These dots are just like I'm drawing them on the graph so I know where to connect to make my line. What we do need to pay attention to is the type of line, and that's why we have a dashed line. We don't have to worry about what kind of dots we draw, just what type of line style. Okay, so the remaining part for this graph is I have to determine where to shade, right? So just like we shaded on a number line is either left or right, and on a linear inequality, we're either going to shade above the line or below the line. And I know you're going to say, well, but the line is slanting, so it's not really above and below. And I'm like, oh, sure. I mean, I get that. But since the equation is written in y form, y is greater than this, or y is less than that, or whatever, the rest of the inequality is describing what's happening in terms of the y coordinate. And so the y-axis goes either up or down. So those are our two options for shading, either above or below. So let's look at what those would how those would appear, and then we'll figure out how to know which one is correct. So from that line, if I were to shade up, it would look like this. I'm going to shade from that green dashed or dotted line. I'm going to shade up. The alternative is if I was shading down, it would look like this. From that green dotted line, I shade below it. Okay, but how do I know which one is correct? Well, so that is what we need a test point for. So I'm just going to come back to this page and let's do a test point. So you can use any point you want anywhere on the graph. It doesn't matter. Pick your favorite point, find the coordinates of it. I'm going to use 0, 0 because that's going to make my job here much simpler, using 0 for x and 0 for y. So I'm going to take those two coordinates and put them into the inequality in the place of x and y. And multiply right there. Okay, so really the question I'm answering here is that test point in the part of the graph that I should shade? That's what I'm trying to answer. All right, so I'm going to put the coordinates into the inequality. I'm going to evaluate, follow the order of operations. So 2/5 times 0 gives me 0, and then I subtract. So 0 minus 1 is -1. So now I ask myself, is this a true number sentence? Is 0 greater than -1? Yes or no? Right, well, 0 is greater than -1. So this is true. Yes. Right. Since this is a true number sentence, that's also answering the question, is this test point in the part of the graph I should shade? Okay. So I asked the question, is it a true number sentence? But really the question that is getting answered here is that test point in the part of the graph that I need to shade? And it is. So I'm going to go ahead and shade the part of the graph where the test point is. The test point is above that green line, so I would shade above. I won't go over that work there, but I don't need to keep that test point there, so I'll just shade over the top of that. And if you want to like fill this in totally solid, be my guest. I'm going to leave it just with some cross hatching. Okay, let's see a different example for a different test point. The same graph, but different test point. What if we had chosen a test point down here? That would be below the line. So this test point has the coordinates 5, -3. Okay, so what would this look like? So I'm going to take those same coordinates, the 5, -3. I'm going to do the same thing. I'm going to take the 5, put it in here for x, the -3 into that inequality for y. 5 goes right there, -1. Okay, so you can choose any point you want. I've chosen this one on purpose. So I know that 5, -3 is going to make it easier to work with because of the slope. It has a denominator of 5, so these 5s right here are going to cancel. And then I get -3 greater than 2 minus 1. And subtract 2 minus 1, that's 1. So -3 is greater than 1. So I ask myself again, is this a true number sentence? Yes or no? -1 greater, sorry, -3, is that greater than 1? No, -3 is not greater. No. So when I answered no, really the question that's getting answered is this test point in the part of the graph where I'm supposed to shade? No, because I didn't get a true number sentence when I used those coordinates. So this test point is below the green line, and it is not the side of the graph that I'm supposed to shade. So I'd say, okay, if I'm not going to shade down here, then that means the alternative is I'm supposed to shade above. Right, so I'm going to end up with the same result no matter what I use as a test point. The way I recognize the place to shade is going to look different. So if the test point is in the wrong spot, then I'm going to get the answer no, it's not a true number sentence. And from that first example, if my test point is in the part that I'm supposed to shade, I will end up with a true number sentence. All right, so let's take a look at one or two problems here out of the WAMAP assignment so that we can see just how to do these in WAMAP. So graph the inequality y is less than -4/3 x plus 3. Here, that is our inequality. And we're going to make sure we follow the directions. This is the first thing I told you to do, the same thing that shows up in the directions here. Make sure to select solid or dashed line from below first. So let's determine, based on that inequality symbol, what type of line should we be using. So it says less than, right? Not or equal to, just less than. So it's not going to be a solid line. We need to have a dashed or a dotted line. So the first thing I'm going to do before I even start putting any dots on the graph is I'm going to come underneath the graph here and select the appropriate line style. So on a dashed line, sometimes it's hard to tell which one is active. So I'm just going to go ahead and click on that just to make sure. No, I've clicked on it like 5 times. Okay, it's selected. Awesome. So start from the y-intercept, +3. So I'm going to move my pencil onto the 3 on the y-axis. Click. And the slope tells me what directions to use to get that next point. Since it's a negative slope, I'm going to go down. 4 is the rise, although in this case, it'll actually be down, not rise. But down 4 spaces and then to the right by 3. So down 4, right by 3. Okay, so you can see the dots following me around. I'm going to click to hold that in place now. And next, I need one more click. As you can see, if I move this pencil back and forth, it changes the shading. So I don't know which one is correct at this point. So I will need to determine which one is correct and then select into WAMAP the appropriate side for shading. So let's get some workspace here. And y is less than 4/3 x, fraction line, plus 3. So I'm going to go ahead and use 0, 0 as my test point. Which would be below. So if I move my cursor back over here, 0, 0 is going to be right here. So if it turns out this is the correct side to graph, then that's the shading that I want. If it turns out that 0, 0 is not correct, then I'll know I should shade the other part of the graph or above. So let's find out. So I'm going to put 0 in for x and 0 in for y. So that's going to be 0 is less than -4/3 multiplied by 0 plus 3. Do this multiplication first. So 0 is less than -4/3 times 0 is 0 plus 3. And then I can add 0 plus 3. And then I ask myself, is 0 less than 3? Yes or no? Well, that one's not so hard to answer. I know that 0 is definitely less than 3. So I'm going to say yes. And I know that when I answer that question, I'm also answering this other question. Is this test point in the part of the graph that I should shade? Yes. All right, so I'm going to go back over here. I do not need to actually click on 0, 0. WAMAP doesn't care that I use 0, 0 as the test point. So if you want to click any place, as long as you're going to get this bottom part shaded here, I click in just off from 0, 0. Actually, I got 0, 1 this time, which doesn't make any difference because I could have used 0, 1 as my test point. I still would have got the same result. So now I can submit. All right, get to it.